Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as concurrence from each one of you regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go ahead. Anyways, the agenda behind today's video is almost same. As we have been pursued in last 4 to 5 number of days, we are going to take few number of word problems based on the concept of the probability. Only 2 questions has been taken in last video, but both of the questions were utterly well designed problem. In the same sequence, we are going to take the question number 3, 4, 5, 6 and even if the time permit, we would also take the question number 7. Anyways, before starting today's session, I would like to have the input as well as concurrence from each one of you regarding the quality of video as well as audio. If it is perfect, just write perfect and then we are ready to go ahead. Yeah, perfect. So now the first question comes on your screen and this has been the question number 3. This problem has been experienced by civil engineering. Year of 2008, the problem was framed by IISc Bangalore. Read this problem carefully. Try to decode each and individual words which had been associated within this complete problem and then find the bestmost answer. What the problem states, a person on a trip has a choice between the private car and the public transport. That means a person might be moving from one place to another place. He had got the 2 different choices. Either he can travel through the car, either he can travel through the public transport. That's well and good. The probability of using a private car is being 0.45. What does that mean of it? That means 45% time he chooses car. That's fine. While using a public transport, further choices are available as a bus and metro. What does it mean of it? That means if he wishes to move through the public transport, there also he has got the 2 different options. Either he can move through the metro train, either he can move through the bus. That choice is also being given, out of which the probability of commuting by a bus is 0.55. That means if he has selected the transport as a public transport, 55% time he chooses bus for commutation. In such a situation, the probability rounded up to the 2 decimal place. Keep in mind this 3 to 4 number of words are utterly important words because many of the times they used to say give the answer in a form of integer. So if you get the answer like 2.1, 2.01, 2.02, there you had to precisely give answer as 2 itself. So sometime it becomes a very bizarre if you are not able to understand the basic crux behind the data which are being clearly given. Of using a car, bus and metros respectively would be. The 4 different options were attached along with this problem. It has been a type of MCQ. That means out of 4 different options, only one option is going to be the correct one. Tell me what would be the bestmost answer for this given problem. Mini electrician, sir, your lectures are awesome. Thanks, dear Mini. Anyways, focus over this problem. And tell me what would be the bestmost answer for this given problem. Anyways, for the better understanding, let me bring this problem towards working board and there we would sort this problem out. So this problem goes in our working board. Tell me what would be the bestmost answer for this given problem. Around 120 seconds has been given to you guys. Within 120 seconds, you must be able to crack this problem out. So all of the toppers, all of the students who would do good in GATE probably would be able to solve this problem within 120 seconds. So the same amount of time had been given to you guys. Tell me what would be the bestmost answer. What would be the bestmost answer? Read the problem carefully. Try to decode the meaning of each and individual words. Specifically, when you have the word problem, no, each and individual word used to have its own significance. So that is why I say the problem related to the word problem is specifically in probability. The meaning of the each and individual word makes hell amount of sense. As per the Prin Kumar, the answer had been A. Anyone else apart from Prin Kumar? So only one answer has been received so far over the live chat and he has been Prin Kumar. Obviously, probably he is the person who have been attending our classes for the EMFT over the live class also. He is doing good. Good, Prin Kumar. Aniket Sahu says the answer would be A. Anyone else apart from Aniket and Prin? See, let me give a little bit basis behind this sort of problem. My dear friends, whenever you deal with the problem where the events are occurring within an event, always try to focus or always try to solve that problem using the tree structure. Why I am saying the event has been happening within the event? First, you can see yourself, you had got the two choice, either you can transport or either you can commute through the car, either you can commute through the public transport. And within the public transport, again you have got the two opportunity, either you can travel through the bus, either you can travel through the metro. So keep in mind, just to understand the complete problem into the better way, what I would say, always try to make the tree structure when the event has been associated within the event. And that is why I have taken this problem as the first problem, so that I would try to narrate few of the important concepts which would become very, very important concept, specifically when the events are getting involved within the event and chunk amount of number of events are getting involved within the problem itself, Yes. So here it has been the solution. Few of the important point I am going to write over here. Whenever you have event within the event, whenever you have the event within the event, always use tree structure. What does it mean by the tree structure? It would have the n number of branches, and each and the individual branches may have the n number of sub branches. Once you'll see this problem, one thing has been quite sure. The person wanted to get commute. He has got the two different opportunities. What are they? Either the person can move through the car, either he can move through the public transport. Here it has been clearly written, the probability of using a private car is being 0.45. So the probability that he would be commuting through the car is being 0.45 or 45%, that he has been moving through the car. Yes. Similarly, if 45% had been the chance that he would be moving through the car, so remaining 55% time he might be moving through the public transport. He might be moving through the public transport. Specifically in this problem, it has been clearly known, even within the public transport, you have got the two opportunities. What are they, sir? Either he can move or she can move through the train, that's the metro train, either the person can move through the bus. Again, the two opportunities the person have got, and that's nothing but the bus. The person can move through the bus or either can move through the metro rail. And even this possibility is also being given. Further choices available are bus and metro, out of which the probability of commuting by bus is 55%. That out of 100 times, possibly 55 times, he commutes through the bus. So obviously rest of the time he might be commuting through the metro. Obviously 0.55 plus of 0.45 has to become 1. Obviously here the data is being given as 0.45 plus of 0.55 should become 1. So this has been my complete tree structure, and you yourself would be able to understand now the complete problem has been diluted in a much efficient way. Even once you will start from here onwards, you yourself would be able to understand each and everything once you will see this tree structure. What had been the meaning? Sir, if I will be going with the car, probability would be 0.45. If I would be commuting myself through the public transport, my chances that I would be commuting through the public transport is being 0.5. And similarly, if further choice is being the bus, possibility would be 55%. Further choice would be metro, the possibility would be 0.45%. So till this point, I don't find any of the student would have any sort of doubt now. Now, once you'll see in this problem, what exactly they have been asking for. In this situation, the probability rounded up to the 2 decimal of using a car, that means the first data which you had to calculate, that the person is moving through the car. Anyways, yeah. Person is being moving through the car. So here it has been the probability that the person has selected car for the commutation. What would be its worth? What would be its worth? It is been clearly known, no? It's been clearly known. The probability that the person would be moving through the car would be 0.45. That data itself has been clearly given along with this problem. Is given along with this problem. Yes. Next, the next data which we are supposed to calculate is nothing but we wanted to have the probability that the person is moving through the bus and metro. Probably the student may have a little bit confusion, sir, and is being used. But once you'll see its option, no, it has been clearly known that we need to calculate the probability that the person would move through the bus separately and the person would move through the metro is going to be separately. So again, the same process is being used. Here is going to be probability that the person must be moving through the bus. How it's possible? All the way first person has to select the public transport. Its possibility is going to be 0.55. Once the public transport is selected, now then only he had got the opportunity that he can select the bus. How had been the possibility? Possibility that he would select the public transport is being 0.55. Possibility that out of the public transport he is going to select the bus is being 0.55. Anyways, both of them are going to get multiplied together. So here it's been 0.55 into of 0.55 would be raised to the power of 2. How much data we have been getting out of it? It's been 0.3025. That's what I am saying. This 2 or 3 number of words which has been attached along with this problem make hell amount of sense. It has been clearly said you had to round the answer up till the accurate value of 2 decimal place. So what we are going to do over here, the remaining numbers has been rounded off. Although this answer would have a little bit amount of truncation error, but still it's okay as it's been clearly written in your problem. Nobody should put extra mind over here. No sir, I tried to put the answer as 0.3025. You are the last person in the Baikoof list. Don't do that, because I have seen many of the times the student have lost the marks just because they have put more number of brain. Agreed? In the same sequence, let me move forward. What it has been, sir? Now we wanted to know what would be the probability that the person must be moving through the metro. Again the same thing goes on. The person would move through the metro only. First he must select or she must select the public transport, and its probability is being 0.55. And once the public transport is got selected, now the possibility that he or she must be moving to the metro is again 0.45. So end of the day 0.55 has to get satisfied, then only there would be the possibility of 0.45, and as you have been satisfying both of the possibility, they would just get multiplied without any hassleness. So end of the day, result which is supposed to come in our hand is being 0.5 would remain as it is. Now it's going to get multiplied with the 0.45. End of the day, the result what we are going to get out of it is being. Tell me how much answer we have been getting. 0.55 it is, my dear friends. I fed the value as 0.5. Okay. So it has been 0.2475. As this digit has been greater than 5, obviously I can take a round off. So after doing the round off, the data which we are going to get, it's going to be 0.25. So obviously most of the answer had been the correct one. Pooja had given the correct answer. Aniket Sahu had given the correct answer. But meanwhile, the person has changed his thought process. Aniket, I would suggest one thing. Whenever you try to solve any sort of problem, no, be confident on it. Because in GATE examination, you will not have that much amount of time that you will rethink the complete concept again and again over the same problem. You have to face total 65 number of problems, and that too with a short amount of time, that's 180 minutes. So that process definitely it's not going to work, at least in GATE examination. And as you have been preparing for the GATE examination, each and individual your act must fall in the requirement of the GATE. May I know how many of us could really understood this concept? So bestmost answer is being the possibility that I would be traveling through the car had been 0.45. Possibility that I would be traveling through the bus it has been 0.30, and similarly the possibility I would be traveling through the metro is being 0.25. Let me take the another dimension of this problem. See what I am doing over here. Let's take the possibility that I have been moving through the car is being keep increasing. In that case, what would happen? The possibility that I would be moving through the public transport would be keep decreasing. And if it happens so, by default you can see the probability that I would be moving through the bus, probability I would be moving through the metro would be keep decreasing. If you can think in this way also, if it has been decreased utterly, and even if this possibility is increased, no, still you may land up a situation where still the probability for the selection of bus is decreased. Why so? Because this data and this data is going to get multiplied. If the probability that you are moving through the public transport itself is going down, that means the probability that you have been moving through the bus is going to go down. That means in tree structure, one thing has been quite sure, as you have been moving in a certain branch to branch to branch, if any of the data is going to go down, no, your probability is going to go down. Sir, can I subtract 0.55 with the value of bus? No, I did not understand. Pooja, can you rephrase what exactly you wanted to ask? You have put a word over the live chat and you are saying, sir, can I understand or subtract 0.55 with the value of bus? Exactly, I could not understand, Pooja, what exactly you wanted to ask. If you want, you can rephrase your words once again. So definitely I will try to give the proper most answer for your query. Is that part clear? If it is clear, just write clear, and then we are going to go ahead. It must be clear to most of us. Chaliye, in the same sequence, now it's the right time to take the next problem, or I can say one of the most utterly delicious problem, and this problem has been experienced by GATE electronics people just recent year of 2021. So may I know how many students who have attended the GATE electronics year of 2021, and how many of you could solve this problem? Probably few of the student. Prin Kumar, just wanted to know, have you attempted GATE 2021? And if you have attempted GATE 2021, tell me whether you could solve this problem correctly or not. This has been a well-designed problem. And yes, this problem has been experienced by the GATE electronics year of 2021. Read this problem carefully. Try to extract all of the important information which we can extract from the each and individual word, and then give the proper most answer. Clear, sir? Prin Kumar is saying yes, sir, did not get it then. Prin, just would like to ask one thing. That means the concept behind this problem is clear now. Obviously, as per your sentence which you have written over the live chat, it means like you could not solve this problem during the GATE examination of year of 2021. But now would like to ask one thing from you. Do you really understand the basic crux behind this problem or not? Or still you have a little bit doubt? Okay. Yes, sir, but I did not get it. Now I got. That's fine, Prin. Still you are going to learn so many things once I would be explaining each and individual informations which had been given along with this problem. Once we will go with the great detailing of this problem. Read this problem carefully and try to smash this problem out. This would be the fourth question. Yeah. Yes, sir, but I need it to be clarified by you. Okay, Prin, we are going to do the detailing of this problem. See, we'll try to focus over the each and individual words which are involved along with this problem. The problem states, a box contains the following 3 coins. Let's take, we had a box. This box contains the 3 number of coins. But once you'll see the structure of 3 number of coins, they are bizarrely different. See the first one. A fair coin, what does it mean by the fair coin? That means it has a coin which would have the head as one face, tail as a one face, obviously, and their occurrence probability would be 1/2 as well as 1/2. Could you understand what I am saying? Even you can say unfair coin who had the head as well as tail, their occurrence probability may be different. If I take an example, probably you would be able to understand. Let's take you had a coin. This has been the side view of the coin, and the additional weight has been engaged towards downside. So most of the time what would happen, do you understand? When you'll toss the coin, no, the heavy side would try to come down. Let's take the upper face has been head and the lower face has been tail. In that case, the probability for the occurrence of head would get increased and the probability for the occurrence of the tail would get decreased. Although both of the faces had been the fair faces. One face has been head, another face has been tail. But anyways, specifically in the first coin, it has been clearly said a fair coin with the head one face and tail on the other face. That means the probability for the occurrence of the head as well as tail has been very same. That's fine. A coin with heads on both faces. That means it is not a fair coin, it has been an unfair coin, and both of the faces of that coin is being head. Similarly, again you had another unfair coin. How did that be an unfair coin? Because both of the faces has been tail over here. The probability of public transport is 0.55. If I get the probability of bus 0.30, Pooja, let me come back to your doubt. Let me finish this problem, then definitely I will try to come back to your doubt. Agreed? So again, once you'll see this problem, one thing has been quite sure. Even the extraction of a coin from a box and then the outcome from the each and individual coins are bizarrely different. And once you will try to solve this problem with the mathematical expression itself, no, it would become very difficult to even visualize the complete problem itself. So what had been the best way? The best way is to go ahead with the tree structure. Why the tree structure is being the best way? Because in tree structure, no, every event used to come in order, and even you will able to understand which had been the sub event and which had been the principal event. Like selection of 3 coin has been the principal event, and once either of the coin is being selected, the occurrence of head and tail, maybe occurrence of head and head, occurrence of tail had been the sub event. That is what I am saying. Just focus over the tree structure concept. So what I am saying here, you had box. The word what they have used is being boxed. Sometimes they say bag, sometimes they say urn, but here they have used bag. So I am using the same word over here. It has been bag. So obviously, in random you are going to select the one coin. May I know what's the possibility that the first coin would get selected, second coin would get selected, third coin would get selected? Obviously, as far as their structure is being concerned, nowhere it's been given that they have been different. So selection probability of either of the coin is going to be simply 1/3 as well as 1/3. So here we are going to have the 3 bifurcation, or you can say we will be having the 3 branches then the initial tree structure. What are they? Possibility that you would be selecting a fair coin. Possibility you would be selecting an unfair coin which contains head in both of the faces. Possibility you would be selecting unfair coin where both of the faces had been tail. May I know what would be their selection probability? Until and unless you have not selected what? Fair coin, I cannot talk further now. Obviously, we would be discussing over this fact at very beginning. How many number of coins you had? The 3 coins you had. 3 coins you had. Yes, sir. Till this point, each and everything must be very clear to all of us. Obviously, if we'll go down, it had been a fair coin. Once the fair coin has been tossed, may I know what would be the possibility that the head would occur and what would be the possibility that the tail would occur? Obviously, there would be equiprobable possibility when the fair coin has been taken out, and if it is being tossed, obviously the occurrence of the head would be half and the occurrence of its counterpart tail would be half. So here the result I can write over here, it's been half over here, it's been half over here, it's been a fair coin, and I have been talking about the occurrence of head as well as tail. Occurrence of head as well as tail. Could you understand? In the same sequence, we are going to move ahead. Now you have been talking about the unfair coin, and that too unfair coin where the both of the faces had been had. Again, we are in search of head and tail. My dear friend, head had been a certain event, specifically if the unfair head coin is being selected out. Why? Because if you'll toss, if the front or the up surface comes as a hard head, even the down surface is also being head. So obviously, how many times you toss it, always you will be getting head alone. What does it mean of it? That means it has been a certain event where the possibility of the occurrence of a certain event would be 1. What about tail? It had been an impossible event. What would be its probability? It's simply going to be 0. It's not at all possible. Sir, how to understand where to use the tree structure? That's what I am saying, no Manju. If you'll say, I can discuss once again the complete concept. When you have the event within the event, no, always go ahead with the tree structure. Even the tree structure is also useful in Bayes theorem also, where you will be having certain number of event, and within the event you will be having the second event. So even you can correlate the tree structure with the help of Bayes theorem also. Similarly, unfair coin, and if the coin has been unfair tail, in that case again I would be searching, I would be in search of head, I would be in search of tail. In this case the head has been an impossible event because both of the faces has been tail, and tail has been a certain event. At any case you would be getting tail alone. Yes. So this has been the complete tree structure of this problem. Once you have this thing in your mind, no, probably you are going to smash almost all sort of problem. Now try to focus what the problem exactly says. A coin is picked randomly from the box and tossed. Out of the 2 remaining coin, just a minute, a coin is picked randomly from a box and tossed. Out of 2 remaining coin in the box, 1 coin is then picked randomly and tossed. If the first toss result in a head, the probability of the getting a head in second toss is. So just write the complete problem into its equivalent axiomatic form. Here we are in search of probability that the probability of getting a head in second trial when the head is already been occurred in first trial. Could you understand what I am saying? Should I write once again? The probability for the occurrence of H2 when the H1 is already been occurred. If you don't exactly understand H2 has been stand for which event, H1 has been stand for which event, you yourself would be able to understand. H stands for head, and second stands for second trial, and first stands for the first trial. That means the probability for the occurrence of head in second trial when the head is already been occurred in the first trial. Obviously, it had been a conditional probability. Nobody would be able to deny. Its answer is going to be P of H1 intersection H2 divided by of P of H1. P of H1. Yes. Till this point, I don't find any of the student would have any sort of doubt at least. Focus over the P of H1 first. The probability that the first trial you have got the head. How it had been possible? Just try to understand. In which are the different branches you can get the head? First of all, you can get the head if you move through this branch. You can get the head if you move through this branch. Yes. You cannot get the head if you move through this branch, because at any case you are going to get the tail alone. So how many ways you can get the head now? You yourself would be able to analyze it. So the path would be, just a minute, let me mark the path. First you should select the first coin, which has been a fair coin, and then after tossing there had been the possibility that the head has been appeared. Secondly, you should have selected the second coin, which has been an unfair head coin, and obviously if it has been an unfair head coin, there is no doubt that you are going to get the head. That is why the probability which has been associated is been 1 alone. It is been alone, 1 alone, and the possibility or the probability, just a minute, possibility or the probability, यार एक मिनट कहीं प्रॉब्लम आ रही है, रुक जाइएगा, ऑफिस से फोन है, जस्ट अ मिनट. Is that part clear? So actually I had the phone from the office, so I had to pick it up. Agreed now what I'm saying? So here it has been this. Yeah, like this. So if we'll talk about the P of H1, how it's been possible? First, you could have selected this path. May I know what had been the possibility that you would be selecting this path, or the probability that you could have picked up the fair coin? That has been 1 upon 3. And then the possibility that you could have got head, that has been 1 upon 2, or you could have selected the unfair head coin, whose possibility had been 1 upon 3, and once you have selected the unfair head coin, by default after tossing you are going to get the head alone. So obviously towards denominator side you have got 1 upon 3 into of 1, 1 upon 3 into of 1. That must be clear to all of us. Agreed? I don't find any of these students would have any sort of doubt now. Anyways, now focus over the numerator. May I know what would be the part of numerator? I wanted to have the situation when we had the situation that the first coin had the head as well as the second coin also had the head. Tell me what would be its best most answer. Just focus over the numerator only. Tell me what would be its value. That is possible. That means you could have gone through this branch and also you could have gone through this branch. Any other branch has not been left out. That means the possibility you could have selected either this or this and you could have got head. Either you have selected this and you could have got head. So you can say for possibility that the first coin had been the fair coin, its selection probability has been 1 upon 3 and it's 1 upon 2. Yes, print we can. Yes, this problem even can be solved using the Bayes theorem also. Yes, print we can. That's what I'm saying. Tell me what else? And as the end had been come over here, now it's gonna be 1 upon 3 and here it's gonna be 1. Tell me how much answer we have been getting after doing this all calculation. Bizarre calculation. Tell me how much answer we have been getting. So I think 1 by 3 only we are getting, or what? I would like to have the input from each one of you, whether we have been getting 1 upon 3 only or what? D, no? Okay. Now the people are saying, can we use the Bayes theorem? My answer would be yes, we can use the Bayes theorem. So far I did not solve using the concept of Bayes theorem, but one thing is quite sure. We had the event, within the events obviously the Bayes theorem is always most welcome. Bayes theorem is almost most welcome. Yes. So just a minute. So let me do one thing. Let me try to solve this problem using the Bayes theorem. Bayes theorem. So in Bayes theorem, what we are going to have? We are going to have event in background. We are going to have the events in background. How many number of events you had? Obviously the 3 different events you had, they have been mutually exclusive as well as exhaustive. What does that mean by the mutually exclusive? That means the occurrence of one restricts the occurrence of other. What does that mean by the mutually exhaustive? That means once you add all of the event together, no, it completes your complete sample space. Obviously, selection of first coin, second coin, and third coin, they have been mutually exclusive event. Mutually exclusive event. If you select the first, you can't select the second. And similarly, if you select the second, you can't select the third. And 1, 2, and 3 together always smashes the complete sample space. It smashes the complete sample space. And their possibilities, that means their selection possibilities had been very same, and that has been 1 upon 3, 1 upon 3, 1 upon 3. We used to take the event number 1, event number 2, event number 3. So what you can say, it has been event number F, which has been a fair coin. Event for unfair coin, here you can write head. Event for the unfair coin, and that has been tail. That has been tail. That has been tail. Yes, till this point I don't find any of the student would have any sort of doubt now. Now, specifically in this problem, one thing has been quite sure. You have been looking for the calculation where both of the coin must have the head, where one specific data is already been provided that the first coin had been had. The first coin had been had. May I know what it would be? What it would be? Just try to understand this way. So obviously, if you say both of the coin has to be had, there is no other opportunity rather having an event which would fall under the E of F and which would fall under the E of H. Why so? Because within the E of T, there is no possibility that you would be getting any head, and if you are not getting any of the head, obviously requirement of 2 head is not going to get satisfied. It's not going to get satisfied. Agreed? Let's take, it has been event A for getting 2 heads together. Event A for getting 2 heads together. Agreed, no? May I know what would be its possibility? What would be its possibility? Again, we had to use the, just a minute, Bayes theorem. 2 students were insisting, sir, can we use the Bayes theorem? That is why deliberately I am solving this problem using the Bayes theorem. So here the P of A2 would become, here it would be P of EF intersection of A2 and plus of P of EH, it has been, no, EH of A2. Or you can simply say it has been an event for getting head in first as well as second. You could have written that as A itself. No issue. What would be its worth? Obviously, we can change this problem in a form of dependent event, and that would be equals to of P of EF, which is getting multiplied with the P of A2 by of EF plus here it would become P of EH, and here it would become P of A2 of E of H. Agreed? Till this point, probably this must be clear to all of us. What had been the P of EF? P of EF is being selection that you have selected a fair coin. What had been its probability? Obviously 1 upon 3. P of A2, probability for getting head if the fair coin is being selected, it's been 1 upon 2. It's been 1 upon 2. That is also okay, sir. That is also okay, sir. Plus of. Next. P of E of H, what had been its possibility? It's again 1 by 3 it's been 1 by 3, and P of A2 when the EH is being occurred, it's a insured event, it's a one shot event. Obviously it would take place at any case, so obviously you have got the same value which we were getting towards denominator side. No, you have got this value, you have got this value. Agree? So probably I don't find that any of the student would have any sort of doubt now. So at least the denominator part is clearly known to us. Known to us. Now only we have to focus over the first one or the numerator one. That the probability in first trial you could have get head, and in second trial also you could have got the head. You could have got the head. And again, once you'll do this complete calculation, you would be getting the same answer. And yes, you have come across the same answer. So if somebody says, sir, is it possible to solve this problem using the Bayes theorem? So I would say, yes, sir. Or yes, students, it was possible. And more or less, the concept of tree and the concept of Bayes theorem is being connected to each other. Nothing new, nothing great. So can I say the concept behind this problem was clear to all of us? Yes, a little bit amount of axiomatic approach must be known to us so that the complete calculation would become much easier. Tell me, till this point each and everything is clear? Yes, Prin, it was possible. Although I did not solve this problem using the Bayes theorem, but it's quite sure, no. You have been dealing event under the event, so obviously anytime Bayes theorem is most welcome. Yes, sir, clear, no? And now most of the time you can see practically the front count event used to have an intersection over all of the event, but here it's not been, because here you can't get the head at all. Yes, Pooja is also saying ready. Okay. The fifth question would be the question which has to be solved by you guys, and you have to put your answer over the live chat. Yes, Pranali. Okay, that's fine. This has been the fifth question. You had to solve this problem out. And give me the best most answer over the live chat. Anyways, I am not going to solve this problem today. Probably we would take its complete solution tomorrow. But still, I would like to have this input from you guys, and I know many of the students would not be able to give the proper most answer for this given problem. I know many of us would not be able to do so. It's not that straight problem. I won't categorize this problem as a difficult problem, but yes, it's not a linear problem also. Tell me. Not a linear problem also. Here we have been focusing over the numbers. Probably the student who have started solve this problem, definitely they would be stuck themselves, or they would be stucking themselves while counting the number of heads and number of tails. So it's not that straight problem. And the student who are well acquainted with the binomial distribution, probably they would be able to smash this problem into the utterly simpler form. But anyways, I would not solve this problem using the binomial distribution. I would use the classical method of the probability during solution of this problem. Anyways, this has been the agenda behind today's video. Yes, the two questions we have taken, and yes, few more tree questions would be taken in future. As per the Aniket, answer had been A. Anyone else apart from Aniket? And just understand, in this way we would have the session of mathematics somewhere 50 minutes. And even the EMFT also we had the session of somewhere 50 minutes. So we are not going to have very long session. We will not be having very long session. Yes. And you can do one more thing. The student who are having problem in a specific kind of the probability which has been experienced by different gate papers or has been taken somewhere else. So you can just put those questions on my Telegram group and you can pin my there itself. Yes, sir, please clear my doubt on question number 3. Okay, let me see, Pooja, what you were saying. Pooja was saying the probability of public transport is 0.55. If I get the probability of bus 0.30, can I subtract the total public transport value? Okay, just a minute. The probability of public transport is 0.55. If I get the probability of bus is being 0.30, can I subtract the total public transport value? Pooja, I did not exactly get what exactly you wanted to ask. Let me read this complete sentence once again, otherwise we would have that discussion over the Telegram group itself. The probability of public transport, as you are trying to say, the probability of the public transport is 0.55. Probably it was, yeah. If I get the probability of bus 0.3, can I subtract the total public transport value? Can I subtract the total public transport value? Yeah, yes. The probability of the public transport is 0.55. If I get the probability of the bus. Okay. Exactly, I could not understand what you are saying, but let me explain by myself. Probably that's the point where many of the students would have any problem. See what I'm saying, what this 0.55 indicates, could you understand? When you have made your mind clear that you have been moving through the public transport, then only this 0.55 and 0.45 do come into the picture. If you have been standing at this point and if you're saying what had been the possibility that I would be moving through the bus, that probability is gonna be all the way this value as well as this value. Now in future you can have the different kind of the problem where you can have, let's take 5 to 7 number of sub branches, and if you wanted to make certain decision at this point, so what you had to do, you had to look into the last most event and see what are the different paths were present till this point. You had to multiply them together. Could you understand what I'm saying? So if you'll say what had been the possibility that you are going to travel through the bus, that has been 0.55 into of 0.55. If you have made your mind clear that you have been moving through the public transport, or if I say what has been the probability that you have been moving through the bus, if you have already made it clear that you would be moving through the public transport, in that case the worth would be 0.55. Keep in mind P of B and P of B when the T is been already occurred had been the two different values. P of B when the T is already been occurred is 0.55 and P of B is gonna be 0.55 into of 0.55. I do not exactly understood that either I could give your proper response or not, but anyways we are not going to extend the today's class from here onwards. If any doubts are still been left out, you can use the Telegram group to reach me, and definitely we can do the practical discussion there itself. Okay. Pooja, tell me, could you really understood what exactly I wanted to say, but I could not understand? We can do, or we can reach out with the help of Telegram. So this is all about the today's lecture. So take all doubts problem of EMFT PDF in live classes. Aniket, all doubts, where did I get that? I did not get so far, no? Clear, no, Pooja? Clear. Probably this was the doubt which you were asking. Pooja, whether this was the doubt which you were asking? You were getting confused that 0.55 is being selection of the bus when you have made your mind clear that you would be moving through the public transport. That means you have made one thing clear that you are not at all moving to the car. Yes, sir, please do take all the doubts of EMFT where it has been clearly written, yaar, that which are the doubts you had. Okay then. Chalo fir. Chalo. Okay, then bye bye. Take care. Good night.